Hi, this is Craig again. I'm going to be talking about using the NOx setup for typical operation of the NOx setup. And as you can see, we have the nitric oxide monitor, we have the NO2 converter, and they're connected using the serial cables that we explained in the first section, or the section previous to this. And they're also connected to the monitor, the laptop, which is running to be data display program. Now, the nitric oxide monitor, we've skipped the warm-up. We're now in parameter adjustment mode, and we're outputting ozone, total flow rate, sample flow rate, temperature, pressure, and the ozone flow rate. As you can see in the screen here, now when you're in parameter adjustment mode, you have to use the buffer tab on the data display program to view the data that's coming in. If you notice on the data grid, the only time you're going to get data in the data grid is during the NO mode, because it's going to fill each column that it's expecting. Otherwise, you're just going to use the buffer to view the parameters that you're ensuring are correct. Now, typical operation, if this is set to automatic adjustment, it will actually skip out of parameter adjustment mode after 15 measurements of ozone. So what it's doing is it's measuring how much ozone is being produced, which reacts with the sample coming in. That has to be very stable in order for the system to work properly. It also is making sure the flow rate that is going through the reaction coil is very stable, and it makes sure that the ozone flow rate is stable. So if the parameters aren't stable during that mode, then your readings aren't going to be stable during NO mode. And if they're incorrect, then you're not going to get correct readings during NO mode. So as we can see, the ozone concentration that it's producing is 3,912 ppb. It tries to maintain between 3,800 and 4,200 ppb in order for it to work properly. And the flow rate, as you can see, the sample flow rate is 972, and it wants to be close to 1,000 cc's per minute, and it can be plus or minus 100 cc's per minute. The total flow, which is 5th column over, that is going to be around 600 cc's per minute, and give or take 20 cc's. The ozone flow rate should be in the range of 10 to 30 cc's per minute. Now, if it's out of this range by a little bit, you're going to want to go back into service mode to adjust those flow rates, and we can talk about that in a later section. But this is what you're shooting for here, and it automatically does it. And right now I'm going to skip out of this mode because everything looks good, which you can do as well. Otherwise, you can wait 15 measurements, and it'll automatically go to the next mode. By pressing the button, I'm going to the next mode. Measuring nitric oxide. Now we're going to look at the data coming in from NO mode. So we're measuring nitric oxide right now, and we're using the data display program. Right now we're in the buffer tab, just looking at the raw data coming in. Now, if you're in NO mode and you have all the settings set up correctly on the instrument and the data display program, if you click on the data grid tab here, you'll notice that the data is filling into the columns where it is labeled. So the first column we have is log number. This will be blank unless you are actually logging on the instrument. In that case, it's just a number representing which logged point is coming in from 1 to I think it's 16,000 data lines can fit on the instrument. So the second column is NO. Now this could either, if you're using the NO2 converter, this could either represent NO or NOx, and that depends on which mode this thing is in. Second column or third column is the cell temperature. Third column is the pressure, sample flow, total flow, ozone flow, scrubber temp, generated ozone, and date and time. Now we have a charts tab, which you can display your data in real time. There you can display two different parameters. In this case we have just NO being displayed. Now I can pick another parameter to display. Let's do cell temperature. And once there's enough data in here, we can zoom in and out. And there's a settings button here which will enable you to either have it auto range, and some people don't like the auto ranging because if you have a huge point in there that you don't want to be part of the display, you can just take it out and set your own range. So that's available. Put it back in auto range, close it up. On the x-axis you'll see we have the date and the time. Now when you want to stop and save your data, you just press stop under instrument data capture. It asks you where you want to save, if you want to save a CSV file, which is an Excel file, and we'll click yes. And the default name is going to be the date and time that started measuring. So I'll just save it, and now it's stopped, and you can close it up and you can open up your Excel data, or you can open that file again to view it anytime after. Okay, in this section I'm going to talk a little bit more about the operation of the NOx system, and in particular I'm going to get into how to set up the like a typical setup for setting up your conversion, how often you're reading NOx. So with the instrument running, you can enter the menu by holding the button down until it says menu, release the button, and it will display the sub-menus here. So the particular menu we want to go into is MOL, short for Molly, or short for molybdenum. If we select that menu, there's three different possibilities here. We have NOx, zero, and duration. I'll scroll to NOx, and what this does is allow you to select if you want to measure NOx or you just want to measure NO. Now when you select, if you just select NOx frequency off, that means that you're not going through the molybdenum converter here. There's a valve in here that just switches it to bypass the converter, so all you're measuring is NO. You're not going to be converting NOx to NO. So if we press the button and select on, and we exit this menu and go back to measuring, then all you're going to be measuring is NOx. It's not going to go back to NO at all. It's just permanently on. That means the NOx is coming through the converter, converting all the NO2 to NO, so you have NO2 plus NO, which is NOx. And as we can see in the serial data, it will display for your Molly status. If I exit out of here, begin measuring. On the screen, it's going to output NOx on the LCD screen, NOx equals 0 ppb, whereas before it just said NO. You notice on here, the data lines, it's displaying a 16 for the Molly status instead of a 0. And there's a chart that explains the different status bytes that you can interpret into what mode the instrument is in. fairly easy to understand. But when it's fully on, it's just a 16, so you can tell in your serial data. Now, there's a couple other different possibilities for the NO2 conversion, and it's just basically different frequencies of switching back and forth between NOx and NO. So we'll go back into Molly mode, into the Molly menu. Click on NOx. I'll scroll through. We have 5 minutes. That means every 5 minutes it's going to switch the valve to being going through the converter or not going through the converter. Another selection is 15 minutes and 1 hour. So that just means every hour it's going to switch the valve. So I'm going to go back to 5 minutes, or 15 minutes, sorry, here. Exit here. Now the next menu is 0. This, inside the NO2 converter box, we also have a valve that will switch between a scrubber and NOx scrubber. So no matter if it's going through the converter or going around the converter, it's going to go through the scrubber, so you're always going to get 0 NOx. So the 0 frequency right now is off, and I will switch it to, if I switch it to on, that means it's always going to be going through that valve. And there's, just as before, there's going to be a status byte that interprets it that it is zeroing, and on the front screen it's going to say 0. I can show you that. So even though we have NOx on at 15-minute intervals, we also put the 0 on, so the 0 is, if it's going through the 0 valve, that means it's going to be 0 no matter what, even if it's going through the converter. Right now we have it in 0 mode, and it's displaying a 0 here, and on the serial data the Molly status is 32, which in your chart will denote that it's 0 on full. I'm going to go back in the menu and show a little bit how to change the frequency. We can scroll through here. We can set it to every 30 minutes it's going to do a 0. That's pretty frequent. Basically, you're just looking at making sure that if it is drifting, you're noting how much it's drifting. It's going to tell you if the 0 drifts a couple ppb here and there. So typically for long time measurements, we recommend every 4 hours. So I'll set it to every 4 hours. And DUR is duration, and this just is how long you're going to do the 0 for. You can do it for 1 hour, 5 minutes, 15 minutes, or 1 hour. And we recommend 15 minutes is a good amount of time for it to level out and give you a good 0 measurement for long-term measurements. And we'll exit out. So what this will do is every 15 minutes it's going to switch between measuring NO and NOx, and you'll see on the screen when it's measuring NO and when it's measuring NOx, and then also in the data, serial data, you'll notice the Molly status byte is changing when it does change. And also, as you recall, we set the 0 mode to go off every 4 hours. So then every 4 hours it's going to stop doing NO and NOx and do a 0. And that's how you do a typical setup for the NOx.